Hey everyone, ready for a deep dive?
Always. What are we looking at today?
GPUs. We've got a whole stack of articles and research here.
Oh, cool. Well, where'd you pull that from?
Well, we've got some Wikipedia, some Microsoft support stuff,
Nice. Those are good starting points.
and a couple of really in-depth tech articles too.
Sounds like a good mix.
Our mission is to really understand what a GPU is.
Yeah.
How's it different from a CPU?
Right.
And, why it matters.
I mean, especially these days.
Yeah, exactly. Especially if you're into things like,
Gaming.
gaming,
Sure.
video editing,
Uh-huh.
even AI.
Absolutely. It's impacting a ton of stuff.
So I was prepping for this deep dive, and I gotta admit,
Yeah.
I found some historical tidbits. I was blown away.
Oh, really? Like what?
Did you know that the term GPU was actually coined by Sony
Oh, interesting.
for the original PlayStation?
Wow. Back in 94, I think?
Yeah, that's right, 1994.
It really was a game changer. Literally.
For sure.
Allowed for so much more in terms of sophisticated 3D graphics.
Okay, so first things first, let's just break down the acronym
All right.
GPU stands for.
Graphics Processing Unit.
Okay.
Pretty straightforward, as the name suggests it was. Initially designed to handle the heavy lifting when
Yeah,
it came to image processing,
right.
especially for 3D graphics, video, that kind of thing.
So that's how we get to enjoy those amazing visual effects in video games, or smoothly edit those high-definition videos.
Yeah, it's all thanks to the GPU.
It's doing the heavy lifting behind the scenes.
Exactly.
Okay, so it's also important to distinguish
Yes.
between a GPU and a graphics card.
Yes. Good point.
So the GPU is the actual processing unit,
Right.
whereas the graphics card is the whole board that contains the GPU and a bunch of other components.
It's got the memory,
Yeah.
cooling systems, all that.
Yeah, okay, so the graphics card is the physical thing you install,
That's it.
and then the GPU is the brains of the operation. Okay, cool.
Yeah.
Now, you might be wondering how this differs from a CPU,
Yeah, for sure.
a central processing unit.
I mean, they're both processing units,
Right.
so what sets them apart?
We hear those terms all the time, but
Yeah.
understanding that distinction is really key, I think.
Absolutely. So think of the CPU like the brain of your computer.
Okay.
It handles general instructions, it manages tasks, it makes sure everything runs smoothly.
Okay.
The GPU, on the other hand,
Yeah.
it's like a super efficient art department.
Oh, I like that.
It's dedicated to making everything look visually stunning.
Okay, so the CPU is like the general manager.
Yeah,
The GPU is the team of artists bringing the visuals to life.
exactly. And they work together, kind of like a dynamic duo.
Yeah.
The CPU gives overall instructions, and then the GPU focuses on all the visual tasks,
Makes sense.
allowing for way more
Yeah,
detailed, complex graphics than the CPU could handle on its own.
that makes a lot of sense. Now, our sources mentioned two main types of GPUs.
Right.
Integrated and discrete.
Yes.
So what's the difference?
So integrated GPU, as the name implies,
Mhm.
integrated right into the motherboard or even the CPU itself.
Uh-huh.
These are great for everyday tasks
Okay.
and saving power, which is especially important for laptops.
So if I'm just, browsing the web, checking email,
Yeah.
working on documents,
Exactly.
an integrated GPU might be all I need.
Most likely, yeah. Intel HD graphics is a good example.
Right.
You'll find that in a lot of laptops
Got it.
and some desktops.
Okay, and then we have the discrete TPUs.
Yes.
The heavy hitters.
Yeah, for the serious graphics work.
Exactly.
Those are separate units, usually on a dedicated card,
Okay.
offering significantly more power.
Right.
And they're essential for those really demanding tasks,
Yes,
like
yeah.
gaming, video editing, or 3D rendering.
So if I'm a gamer or a video editor, I definitely want a discrete GPU
You got it.
from companies like, NVIDIA with their GeForce series or AMD with Radeon.
Absolutely.
If you're doing anything that needs serious graphics muscle,
Yeah,
discrete GPUs is the way to go.
for sure.
Okay. Now, one thing that really caught my eye
Yeah.
is how GPUs have moved beyond just graphics.
It's pretty amazing.
The sources talk about something called GPGPU,
Ah,
or general purpose computing on GPUs.
right. GPGPU, rapidly growing field.
So it's not just about pretty pictures anymore.
No, not at all.
I mean, GPUs are being used in everything.
Scientific simulations,
Yeah.
financial modeling,
Wow.
artificial intelligence.
Wait, so the same technology that powers
Yeah.
those incredible graphics in video games
Mm-hmm.
is also helping scientists
Uh-huh.
simulate complex systems and even train AI models.
That's right.
That's wild.
That ability to process vast amounts of data in parallel
Right.
makes GPUs incredibly valuable for all sorts of applications like that. And we'll be exploring those
Oh, cool.
in more depth later in our deep dive.
Often looking forward to it.
Yeah, me too. Welcome back. We've been talking about GPUs, those powerful chips that handle like all the visual stuff on our computers. And we've talked about how they're different from CPUs and the two main types, integrated and discrete. But how do these GPUs actually like do their thing?
Yeah, I'm curious about that too. What makes them so good at, all those complex visual calculations? I saw something about shader units in the articles.
Oh yeah, shader units.
Sounds kind of mysterious.
Yeah, they are kind of at the heart of a modern GPU's power.
Okay.
There are these like specialized processors within the GPU that execute these programs called shaders.
Shaders. Okay, so they're like little programs.
Yeah, think of it this way.
Huh?
Imagine you're an artist, you're painting a 3D scene, right?
Okay.
You've got to consider how light falls on the objects, the shadows, how different materials reflect light, all that. Shaders are like instructions that tell the GPU how to render each pixel,
Okay.
taking all those factors into account to create a realistic image.
So they're like the artistic techniques that give the image depth and realism.
Exactly. Instead of just blindly following some pre-programmed instructions,
Yeah.
shaders give developers way more control over the visual effects.
Hmm.
So they can create things like realistic reflections,
Yeah.
lifelike materials, stunning lighting effects. That's why games and CGI in movies look so incredible these days.
It's those shaders working their magic behind the scenes.
Exactly. And the more shader units a GPU has,
Yeah.
the more complex these shader programs can be. It's like having a bigger team of artists working on a scene.
Okay, so when I'm comparing GPUs and I see one has, say, 4,000 shader units
Right.
and another has 2,000.
Yeah, that's a pretty good indicator of their power.
Yeah.
The one with more shader units can probably handle more demanding stuff, like, the latest games
Yeah.
or professional rendering software.
Makes sense. But I've also seen terms like
Yeah.
CDA cores or stream processors.
Oh, yeah.
When I'm reading about GPU specs, are those the same as shader units?
They're closely related.
Okay.
So CUDA cores,
Mm-hmm.
those are developed by NVIDIA, and stream processors, those are used by AMD. Essentially, they're the individual processing units within a shader unit. Think of them as the individual brushes in our artist's toolkit.
Okay.
Each one handles a tiny part of the task, but together they create the whole picture.
So it's like breaking down the shader unit into its individual parts,
Exactly.
each one doing a little bit of the rendering.
Yep. Each CUDA core or stream processor, it's executing a small part of a shader program. And the more of those cores a GPU has, the faster it can process those complex calculations.
Okay, it's like having a bigger team of artists, each with their own specialty, working together to create the final image.
Exactly. And with GPU,
Right.
which we talked about,
Mm-hmm.
the importance of those cores extends beyond just graphics. Remember, GPUs are now used for scientific simulations and AI, right?
Yeah.
And in those applications, the number of processing cores becomes even more crucial.
Because they can handle all that data.
Yeah, they can crunch through massive data sets in parallel.
Right. We talked about how GPUs are being used in like everything, from astrophysics to drug discovery.
It's crazy, right?
Yeah, it's amazing to think that the same technology that gives us those awesome visuals in games is also helping, scientists make groundbreaking discoveries.
It really shows how powerful and versatile they are. And it all comes back to that unique architecture,
Yeah.
the way they're designed to handle parallel processing. That's what makes them so good at working with those massive amounts of data at the same time.
Okay, that makes a lot of sense. So how do we actually measure how well a GPU performs? I mean, are there like benchmarks or metrics to tell us how powerful a particular GPU is?
Oh, yeah. There are a few ways to evaluate that. One common metric is frames per second, or FPS.
FPS. I hear gamers talk about that all the time.
Right. It basically tells you how smoothly a game runs. Higher FPS means the GPU can render more frames each second, so it results in a smoother, more responsive gaming experience. Imagine watching a movie where the frames are like flickering
Yeah.
or skipping.
Yeah, that would be annoying.
That's low FPS. But with high FPS, everything's fluid, it's seamless, much more immersive.
Right. So if a GPU can deliver, say, 120 FPS in a game, it means it can show 120 unique images per second.
Exactly.
Wow, that's impressive.
It's like the difference between watching a slideshow and a high-def movie, but FPS is just one metric, of course.
Okay, so what are the other ones?
Another common one is TFLOPS, which stands for teraflops,
Okay.
or trillions of floating point operations per second.
Okay, that sounds pretty technical. What exactly are floating point operations?
Think of them as like the complex math calculations that the GPU is constantly doing when it's rendering graphics.
Huh.
A higher TFLOPS number means it can do more of those calculations per second, which means faster, more efficient processing.
So TFLOPS is kind of a measure of its raw computing power.
Exactly. It doesn't tell you everything, but it gives you a good idea of how powerful the GPU is.
Okay, so when I'm comparing GPUs, it's helpful to look at both FPS and TFLOPS.
Exactly. It gives you a more well-rounded view of its capabilities.
Now, you mentioned that the way GPUs are designed makes them good at parallel processing. Can you explain that a little bit more?
Okay, so imagine you have a huge task.
Right.
Building a house. You could try to do it all yourself one step at a time.
Yeah.
But that would take forever.
Right.
Or you could hire a bunch of workers, each one specializing in a different area, and have them work on different parts of the house at the same time.
Right. That would be way faster.
That's parallel
Right.
processing.
Yeah.
Instead of doing one thing at a time,
Yeah.
the GPU breaks down the task into smaller pieces and has its cores work on all those pieces simultaneously. So it's much faster and more efficient.
Okay. That's why they're so good at things like rendering 3D graphics, running simulations, and AI.
Exactly. Tasks that require a ton of data processing.
Got it. It's like having a whole army of tiny workers collaborating.
Perfect analogy. And this ability to do parallel processing is what makes GPUs so powerful and versatile, opens up a whole world of possibilities.
So it's not just about prettier pictures anymore.
No, not at all. It's about, enabling completely new kinds of computing that we couldn't even do before.
It's really changing what computers can do, accelerating scientific discoveries, powering the next generation of AI.
Yeah, exactly. We're just scratching the surface here. There's so much more to explore.
On that note, why don't we take a quick break and then come back to dive even deeper into this amazing world of GPUs. Welcome back. We've been on this journey exploring these GPUs, how they're different from CPUs, and I'm starting to see why they're considered so revolutionary, especially with this parallel processing thing.
It really is fascinating, isn't it? And one thing we haven't touched on yet is memory.
Ah, memory. Yeah, that came up a lot of the articles.
Yeah, it's a big deal.
There's a lot of talk about VRAM
Right.
or video RAM. Is that different from the regular RAM in my computer?
It is. It's a GPU's own dedicated memory,
Okay.
separate from your computer's main system, RAM.
So it has its own little stash.
Yeah, think of it like a high-speed workspace,
Okay.
where it can access all the data it needs for processing really quickly.
So instead of having to share with the CPU
Right.
and potentially slow things down,
Exactly.
the GPU has its own private reserve.
It's like having all your tools laid out in front of you,
Right.
instead of digging through a toolbox.
Makes sense. So I'm guessing the size and speed of this VRAM
Oh, yeah.
plays a big role in how well the GPU performs.
Absolutely. Just like with system RAM, the size of VRAM determines how much data the GPU can hold.
Okay.
A larger VRAM means it can handle bigger scenes,
Uh-huh.
higher resolution images, more complex shader programs.
So more VRAM is better, especially for things like
Yeah.
high-end gaming or video editing.
You got it. But speed is important too.
Okay.
VRAM speed is measured in bandwidth, which is how quickly data can be transferred.
Between the memory and the cores.
Exactly.
So it's not just about how much data you can store,
Right.
but how fast you can get to it.
It's like having a super fast highway connecting the memory to the processing units.
Makes sense now. The articles mention different types of VRAM,
Yes.
like GDDR5 and HBM2.
Yeah.
What's the difference?
So GDDR stands for Graphics Double Data Rate.
Okay.
That's a type of memory specifically designed for GPUs.
Okay.
And the number after it, like 5 or 6, that's the generation.
Okay.
Each generation is faster and more efficient.
So GDDR6 is newer and faster than
Exactly.
GDDR5.
GDDR6 has way higher bandwidth,
Okay.
which means faster data transfer, better performance overall.
Makes sense.
It's especially important for the most demanding tasks,
Got it.
like high-res gaming and professional rendering.
Okay, what about HBM2?
Ah, HBM2.
That sounds pretty high-tech.
It is. It stands for high bandwidth memory too.
Okay.
It's a newer type of memory tech, and it's even faster.
How does it work?
Instead of spreading out the memory chips on a circuit board,
Yeah.
HBM2 stacks them vertically,
Oh, wow.
creates a much wider pathway for data.
Okay, so it's like building a multi-level highway
Yeah,
instead of just a single-lane road.
exactly. More lanes for data to flow through.
I like it. So this results in super high bandwidth.
It does. Makes it great for things like machine learning,
Uh-huh.
AI, where speed is critical.
Wow. It's amazing how this memory stuff is constantly evolving.
It really is. It's important to remember that both the size and the type of memory
Okay.
really make a difference in a GPU's overall performance.
Yeah, I'm definitely going to be looking at those specs differently now.
Good. It's good to be informed.
This whole deep dive has really given me a better understanding Of GPU, I mean, they're clearly so much more
They really are.
than just graphics processors.
From those amazing visuals in games to the scientific breakthroughs, GPUs are really at the heart of so much innovation.
Yeah, and their power and versatility just keeps growing.
It's exciting to think about what the future holds.
Well said. It's been a great deep dive.
It has.
Thanks for joining us, everyone.
And if you want to learn even more,
Yeah.
we've included links to all the sources we used in the show notes.
Until next time.